Okay, we should already know how to build a basic workflow using Stable Diffusion, but how do diffusion models actually generate images? And what is really being diffused? The core idea behind diffusion models is simple. We take an image and add noise to it, step by step, until it's completely unrecognizable. Because we know exactly what the image looked like in the previous step, we can train a model to reverse the process and minimize the error. During training, we feed huge amounts of diverse images into a specialized neural network called a U-net, teaching it how to denoise the data. To keep computational costs down and make the process incredibly efficient, all of this happens in a compressed, lower-dimensional space called latent space. During inference, we do the reverse. We usually start with just pure noise, and then the clip model guides the U-net during the denoising process, using the text from your prompt to shape that noise into an image that closely matches your description. So the key takeaway from this theory is that when we use a diffusion model to generate an image, it starts from pure noise, and the trained model removes that noise step by step to achieve an image that matches your description. Let's go back to the workflow from the previous video. Image generation is controlled by the KSampler node, but let's just call it the sampler. We can think of the seed parameter as a random number used to generate the initial noise. If we set it to fixed and keep all other parameters the same, we'll get the exact same output image every time. In fact, each generated image file has metadata attached to it, including the seed number, allowing you to recreate that exact image later. Usually, we keep it randomized after each generation to get a few different versions of the image and choose the best one. The steps parameter is the number of denoising iterations. If we set it too low, we get a blurry output lacking details. Increasing the number of steps improves quality and details. But too many steps will just make the generation longer, and the quality might actually decrease. CFG tells the model how closely it should follow your prompt. Lower values give the model more creative freedom, while higher values force it to follow the prompt exactly. However, if you set this value too high, like over 15, the image quality will start to degrade and look burnt. The sampler name is the specific algorithm used in the denoising process. Euler is the most basic and fast option, producing good quality images in about 20 steps. While it's definitely worth researching and experimenting with other samplers later, it's an advanced topic that you don't need to dive into right now. The scheduler is closely connected to the sampler. It decides the tempo and how aggressively to remove noise from the image at each step. This is another advanced topic, so for now, let's just keep it on the default simple option. Pro tip: whenever a new model is released, you can usually find recommended configuration values proposed by either the creators or the community to achieve the best results. Now, the last parameter is denoise, ranging from 0 to 1. It decides how much of the original image structure should be preserved. Let's replace our empty latent space with one of the images we already created and use it as a source for denoising. We can load the image using a node directly from the assets on the left side. But before we can connect it to the sampler, we need to encode it into latent space using the VAE. A denoise value close to 1 will completely ignore our source image. A value of 0 will not denoise anything at all, meaning the source image will just be the output image. If we set it somewhere in between, like 0.5, it will keep the structure of the original image, but apply our prompt to it. This parameter is incredibly useful for modifying existing images and is definitely worth experimenting with. I think this covers all the basics for a standard Stable Diffusion 1.5 workflow. In the next videos, we will look at more modern models and dive into many additional features, because a basic workflow is just the beginning. If you are interested, please subscribe and I'll see you in the next video.